Hi, in this video I'm actually just going to cover some of the steps that I've been doing recently as part of the SSIS blog post. If you have read through the blog post, you'll see that I'm actually trying to use a web service of the internet to create a list or report of various airports around the world. The package and the source code will be available on the website shortly, but this video should help you get started. Obviously, there's a much more detailed set of instructions in the blog post, so that should be your first place to go. But you would still be able to get a hang of what I'm trying to do there in the in the SSIS package by just looking at this video. The first thing I'm doing is I've dragged and dropped a for each loop container over here into the package, and when I open up the for each loop container, you'll see that I've selected the for each item enumerator and not the default for each file enumerator. The for each item enumerator allows me to define a list of entries through which I want to iterate. So the way you can do that is by clicking columns and then clicking add, at which point you get a column into which you can add some values. I've already got a list here, so I'm not going to go ahead and add an additional column, but once you press OK, you'll get this column here, and then you manually enter the countries that you want to go ahead and iterate through. Now, just having a list of countries is not enough. We need to be able to pass this information on to our web service. To do that, I've gone ahead and mapped the output of the enumerator, which is index 0, since there's only one column at the moment, and every row in that particular column will be iterated, and the value would be passed into a variable called user country name. You'll see that it's very easy to create variables. You just right click, go to variables, and you can define a variable by clicking this button here. Give it a name, give it an appropriate data type. In this case, because it's a string, I've gone ahead and selected string. Now that the for each loop container is ready to go ahead and iterate through a list of countries, the next thing we need to do is define a web service task. The web service task can be dragged and dropped from here. It needs to be put inside the for each loop container. In this particular case, you will see that I've got an HTTP connection manager, and that connection manager is this one down here. Basically, it contains the URL of the web service from which I need to download the airport information. Details of this web service are available even on their website as well as my blog, so you can look it up there. If you have any proxy or any other credentials that you need to pass in order to access the internet, you would be typing them here. Once the HTTP connection manager defines the endpoint or the URL to connect to, the next thing we need to do is download the Vista file. A couple of different ways that you can download the Vista file is if you go ahead here and you can see there's a download Vista file. All you need to do is define a file somewhere on the hard disk that you can use to go ahead and tell it to where the Vista file is located. So you can just create a .vista file and then point to that, or you can click download Vista file over here. Either ways, the Vista file kind of defines how to interpret the data from the web service, so you do need that. You can also see here that if you already have a Vista file, the contents of the Vista file can be overwritten when you click download Vista. So that's what this is about. Yeah. Once we've gone ahead and defined our Vista file, we should be able to see these drop-down lists be able to populate. So you'll see that this particular web service has a service called airport, and inside that we got a couple of different methods. The method that we are interested in is the one that's called get airport information by country, which is why we defined a list of countries here in the for each loop container. The rest of it gets populated automatically. It basically tells you the output or the documentation in terms of what you can expect when this HTTP request completes. Additionally, you will also notice that this particular web service method expects an input which is called country of type string, and that is where we use the variable that we just defined called user country name. You can see here that I have to check the box variable so that it knows that it's supposed to treat this as a variable and not a string called user : country name. Yeah. The output of this is going to be an XML file, so we need to go ahead and choose file connection and then define XML file. You can see here that I've defined an XML file here inside this path. So you can simply go to some location on your hard disk, right click, say create new XML file, and then select that path. However, here we have a challenge, and the challenge is that part of the XML file will keep getting overwritten with every iteration, which we do not want. So one way to overcome that particular problem is to go ahead and make this a dynamic file path. The simple way to do that is if you right click and go to properties here, you'll see something called expressions. Under expressions, you'll see the connection string, or basically under expressions you can click the ellipse button here to get a list of properties for this particular connection manager, and the connection that the attribute or the property that we are looking for is connection string. So I want to dynamically change the connection string of the output file. So you'll see here that I've actually defined a hard-coded path called C colon backslash backslash. This is important because as far as file paths are concerned in SSIS, you need two backslashes so that they resolve properly. And then you got the full file name path, and at the last you'll see that instead of just giving a hard-coded airport.xml file name, I've actually given it the country name.xml. So the country name, as you can see here, comes from the variable for whichever value it's currently iterating for. So if it's doing United States, it'll generate a file called unitedstates.xml, and if it's doing for India, you'll find india.xml. So that way I'm actually able to dynamically keep changing the file path based on country. Once this is done, this particular web service and for each loop container is going to iterate, and it's going to give me the output in XML format. However, there is a problem with the XML that I receive from this particular web service in terms of formatting. So I need to format it, and the way I'm going to do it is, if you look here, I've got a execute SQL task here, and I'm sorry, not an execute SQL task, but an execute process task. And this process task, what it's going to do is it's going to call the PowerShell.exe command executable, and it's going to pass a script which is located here in C colon work, basically PowerShell.ps1 script. You'll also notice that I've got something called minus execution policy bypass, which is basically meant to prevent the script from being blocked by the current execution policy of the system, which by default does not allow PowerShell scripts to run. Also, you'll notice that I have selected the default working directory for this particular activity or this PowerShell script to run as the file path where my XML files are located, so that it knows where to start looking for the XML files and make the changes. Let me go ahead and quickly show you what the contents of the PowerShell script is. So just a second. Just opening up the PowerShell IDE. This is a fairly simple PowerShell script, so it shouldn't be too complicated for BI developers to actually start using. In fact, PowerShell is quite powerful in terms of what you can do, so it's always definitely worth knowing, because as you can see here, this particular PowerShell script, what it's doing is that for each child item inside this particular path, you can see here, of type XML, it's picking up each file, and then you can see here I get the contents of this particular variable, and then in that content, for each attribute or each object, I basically look for the greater than symbol and replace it with the actual symbol for it, for greater than, and then I set the attribute value back, and I do that even for the lesser than symbol. And I do have to do this operation one more time because the file that I get from the web service is UTF-16, whereas I actually need UTF-8 in order to be able to insert it properly into the database. So you'll see that in the header of the XML, I'm actually searching for UTF-16, changing it to UTF-8, and then changing the encoding. All this done within PowerShell itself. Quite some time back, the way that we used to be able to achieve this was to use cygwin and cat commands, but you can see that now we don't really need to know the Unix command scripts. You can go ahead and just use PowerShell itself. So this is the script that I'm using to go ahead and shred or parse the XML file and make changes to the contents of the XML file. It's very useful even for flat files, CSV files, and other types of files where you need to look for certain content. So once I've defined the PowerShell file there, that's pretty much what needs to be done there. We'll move on to the next task now. Now that the files have actually been shredded and parsed with the correct formatting, we are ready to load the data into the database. So you'll see that again I've got a for each loop container, except this time I'm doing it for each file instead of every item in a list. And you'll see that I've defined the file path here. So there's the file path, and I'm telling it to look only for XML files and also pick up the fully qualified path. This is important because I need the fully qualified path so that the XML source can pick up the appropriate file. As you can see here that again, like before, once I get the path of the file, I store it in a variable so I can pass it on to the next command. So you'll see I've defined one more variable called user XML path. The user XML path variable then gets passed into the data flow task that we have here. So you'll see that I've got a data flow task. If I open it up, I've got an iterative XML file path which is basically nothing but this XML source here. In this XML source, you'll see that the data access method says XML file from a variable, and as before, the variable fully qualified path is available in this content here, right? You'll also notice, just like how the web service requires a WSDL file, XML requires an XSD. So again, just like before, you can either download the WSDL or you can generate the XSD. So we have a button here which will actually read through the XML content and generate the XSD. This doesn't always work. It requires a very formal structure for the XML in order to be able to shred and generate the XSD. But you'll also be able to do this using a number of websites that are available, where you can simply copy paste the XML and the website would iterate through the elements and nodes and attributes in the XML and define an appropriate XSD for it. Either ways, when you finally have an XSD, all you need to do is click browse and point to the path wherever that XSD is, and once that's done, it knows how to read the XML and understand what the different columns and table structures are inside of it. So for example, in our airport web service XML, the output that we get, we will actually have two columns. You'll see here that there is some data type mismatches in terms of WSTR, which is Unicode string. And my XML contains two tables here. The main table I'm looking for is the one that's defined as table, because that's where you'll see that I've got all the attributes of my XML or the column names for my table available here. So I've got now airport code, name, country, latitude, longitude, runway length, elevation, things like that, right? So the intention here again being basically to just go ahead and show you how XML can shred from the XML source and be represented in a table structure, which we can then go ahead and import into the database. Once that's done, I do have a problem with the XML output that's being returned here, because I've got duplicates in the data, and it doesn't make sense to have duplicates, because I'm only looking for the list of genuine current up-to-date values in the airport file. So I've gone ahead and dragged and dropped a sort operator, which is again this one here, and I've checked the box called remove duplicates. And again, in order to remove duplicates, I need to remove duplicates across all columns. So I've selected all of them and then said remove duplicates, and I've pressed OK. You might notice that when we looked at the XSD, there were some problems with WSTR, the string format. So in order to correct that, I've added a data conversion task, and you'll see here that I've converted some of the input columns into a converted format. This doesn't make any difference at this point, because since I've created this, I've already corrected the issue with the underlying XSD. So this task doesn't really need to be here in this example. It was needed when I started the SSIS package off, because at that point the data types did mismatch, but that's been addressed at this point. So you can still go ahead and add the data flow the data conversion task, because you might want to go ahead and change the data type to match with your table structure. When this is all done, the last step is to go ahead, once you've taken the XML, converted it into table, removed duplicates, and fixed data type issues, we're ready to load it into the database. And the way to do that is you can use an OLEDB destination or any of the other data destination sources, destinations that you have here. I'm using a SQL Server destination because that's one of the fastest ways to load data into the database. I've already blogged about this as well, so you can go ahead and have a look at that. It's there on my website. And if you open up the destination, you'll see that we need to define a connection manager, which is essentially just telling us which server to connect to. And if you don't already have a table, you can click new, or if you've created the table with the appropriate table structure and column format, then you can simply pick and choose the table that you want directly over here. The last thing that you need to do is verify that all the input columns are mapped correctly to the destination. So you'll see here that I'm not mapping any of the converted data types anymore, because I fixed those issues. But you can see here that all the rest of them map to their respective columns. So once this is done, we're actually good to go, because this is basically the stage at which all the data finally gets inserted into the database. In addition to this, I'm also going ahead and doing a cleanup activity, which is essentially just going ahead and deleting the files so that they don't interfere with the next iteration. Normally you would copy paste, remove these files to another location. In my case, because this is just an example, I'm deleting the files. So you'll see that I've got an operation, it's called delete file, and the source is basically the XML path which comes from this for each loop container. So the for each loop container picks a file, inserts it into the database, and then deletes the file from the hard disk. And that's basically all that this task is doing at the moment. Now, the last thing that we actually do here is I've got this convert geo coordinates to point spatial data types, and here what I'm doing is the input that I get, if you look here, is actually in terms of latitude, longitude, seconds, and minutes. Right, so you'll see that it's got latitude, degrees, minutes, and seconds, and this is fine when you're looking at it on a map. But when we try to load this inside SQL Server expects a decimal representation for plotting the data on the geographic data type. So I've gone ahead, I need to go ahead and convert it basically. So again, you'll see here I've got one more data flow task. This will go ahead and cleanse the data or enrich the data, so to speak. And when I open it up, I've written a T-SQL query. This again is available on the blog. It converts latitudes and longitude from the standard format of degrees, minutes, and seconds into the geographical form, decimal format basically. This query is available on the blog, so you can just pick it up and use it as it is. Yeah. The output of this is basically just going to be the airport code and the geography, the spatial data type of the point. So you can see here that I'm saying a point cast longitude as varchar 128 and then as varchar 128 for latitude, and that's basically using the standard formats. Yeah. The output of this is again two columns. One is the airport code and the geographical coordinates, and then I've got the OLEDB command. The OLEDB command, I've already got a table that contains a list of unique airport codes, so all I need to do is update the geographical coordinates. So that's what I'm doing here with update airport plots. Set plot is equal to question mark where code is equal to question mark, where question mark represents the input parameters for this particular query. The next thing obviously is for me to map the input parameters. So the first thing I want to go ahead and do is the airport, the code, the first one in the query is set the plot. So the plot becomes my first parameter here, parameter 0. So you'll see that geo coordinates gets mapped to the first parameter and code gets mapped to the second parameter. And with this, basically, this entire package is ready to go. So if I go ahead and execute this, you'll see that it completely just finishes executing and it'll load all the data. So I'll go ahead and just run that right now. Yeah. And the intention here is that when it's done, what you would see is something like this. So that's going to take some time to fetch the data from the web service, but I'll just quickly show you what the data looks like inside the database. Yeah. So this is the data from my XML file. And you can see here that I've got GMT offset, runway length, so there are some defunct runways where data is not available. The rest of them have some data available in terms of their length. And then you got the position of the airport with respect to geographical coordinates. Yeah. And if I do select star from airport plots, which is the converted geospatial representation of this latitude and longitude, you'll see that I've got a list of the airport code and their plots. And if I go to spatial results, it'll actually plot the data. So you can see here I've got something that looks like the United States, Alaska, Hawaii, and then I've got Germany over here, India, and then a lot of airports in China as well. So this is basically what the geographical data type does for us in terms of plotting that information. So you can simply go ahead now calculate the distance between two airports, and you could even go ahead and use that information to kind of predict flight paths for different aircraft depending on their fuel capacity and things like that. So there's a lot of things that you can do using this. A simple example would be a project where we did it for a company that was actually looking to do geographical positioning of buses in different bus stops. So there again, what we were doing was basically getting the geographical coordinates or the spatial coordinates for every bus every 2 seconds and plotting the path of the bus as it travels through the city. And we were able to compare that with the position of the bus with the bus stop and then predict how long in its current velocity it would actually reach the bus stand, and that way be able to update the screen on the bus stand saying that the next bus to arrive would be this one and the approximate time that would take would be X minutes. So as you can see, there's a lot of stuff that you can do with SQL Server, and this is basically just the scratching the surface. Let's go ahead and move on to how we'll use this in Power BI now.